afternoon. Today you're watching CTV News and your host, Gabriel Bella, and we talk about whether or not dispersants should be used in Canadian waters after a large-scale oil spill. According to the U.S. Geological Survey, it says about 13% of the world yet to be discovered oil lay beneath the Arctic Ocean, and there has been reports saying that there's a ingenuity, construction, and planning a site where they will pump and drill for the oil. Not only there's now a potential oil spill in Canadian waters, they also are determining whether or not they should use dispersants or not. In my opinion, I think it's a bad idea to use oil dispersants to treat large-scale oil spills, especially in Canadian waters. So how all dispersants work is that the dispersant agent is used on oil slicks and spills to reduce the interfacial tension between oil and water, to help break down the oil into smaller, less toxic droplets so it will dissolve into the water. If the plan goes well, the microbes in the water will degrade and eat the oil even more. This all happens because the dispersants attach itself to oil particles and prevent them from sticking to each other. This makes the oil less visible and push the hazardous effects of the oil underwater to the seafloor. Dispersant is also used to reduce the chances of it reaching the habitats near the shoreline and affecting the wildlife and the people. One of the most notable uses of oil dispersants is the use of it during the oil spill of the Gulf of Mexico in 2010, during which they used two types of oil dispersants called coexit 9500A and coexit 9527A. These were less toxic compared to what the EPA approved of, but these were less effective than the other dispersants. Saying that, will oil break down the same as in Canadian waters as the same way as it in the Gulf? No. Depending on what type of oil dispersants you use on the oil slicks and the water conditions in which you put the oil dispersants on, it will yield different results. For example, all other disperse other than coexit 9500 used on dilbit, a type of crude oil found in sand deposits in Canada in Canadian waters, isn't as effective. The reason being is that Environment Canada found that the breaking wave water conditions made the disperse less than half as effective when put on dilbit. Another reason why is that oil will break down differently in Canadian waters is because the temperature of the water. Compared to the Gulf of Mexico warm water and the icy cold waters of Canada, it would contain or clean up more than 5% of the spilled oil, according to the director of the Arctic Program for the Wildlife Fund Canada, Craig Stewart. And the reason being is that because in the Arctic Ocean we cannot clean up all the ice that flows under ice, and in the North Atlantic, rough seas would make it virtually impossible to contain the oil before it spreads. said by Craig Stewart in an interview with the Toronto Star. With this being said, even if the oil is broken down by the oil disperse, the negative effects wouldn't go away. For example, fish is like majorly affected by the oil disperse, saying that multiple laboratories says that the houses and the toxic effects affect them throughout their life stages, including from the egg to the until the end of their life. And also sea turtles. According to the mineral management service, the dispersant can be absorbed by the sea turtles and affect their organs, like the excretory system and the respiratory system. It can affect birds too. Highly concentrated oil dispersants can affect their ability to stay waterproof and maintain a normal body heat, which can result from death from hypothermia, according to the National Oceanic and Atmosphere Administration. The effects of the oil dispersant can also affect humans. One of the dispersants used at the Gulf of Mexico oil spill was co-exit 9527A, which contained a toxin called 2-peroxide of ethanol, which can cause injury to the red blood cells, kidney, or the liver. And with repeated or excessive exposure, according to the manufacturer safety data sheet, which I will provide in the link in the description. So with this being said, are there any unique challenges to drilling for oil in the Canadian offshore deposits? Well, if the oil companies want to drill for oil and natural gases offshore of Canada, except the ones off of the west coast of Canada, saying that the federal government banned oil and gas exports, they have to account for the cold weather, the transportation, and the icy conditions and terrain. In most places of Canada, it can get around 32 Fahrenheit to 28.8 Fahrenheit, compared to where most of the oil rigs and drills are built, mostly in hot climates like Mexico, Iraq, or Iran. The oil companies have to deal with the cold weather and have to adapt to this new climate. Another challenge oil companies have to deal with is the transportation of oil and the gas. Since it's banned to transport gas off the west coast of British Columbia after the oil spill in 1969, most ships have to travel through the Arctic Ocean and navigate through its ice and the weather on ships, which can take multiple days to travel and to complete. If there's accidents that cause an oil spill, it will take hours or days to send ships or ships to contain and clean the oil. So, with all that being said, and the potential risk of not doing anything, is it appropriate to use chemical dispersant to treat a potential oil spill in Canadian waters? Considering that our waters ranked 4th out of the 17 OECD countries on the Water Quality Index, and have a terrible seat in the environmental formats and ranked 15 out of the 17 other countries, it's not appropriate to use oil spills in Canadian waters. If we want to preserve the environment for the future and its marine life, instead we should use eco-friendly methods like skimming, biomediculation, or oil booms that are designed to sweep and contain oil spills and have been very effective in actually helping and removing oil from water. And it is way cheaper than Coexit 9500 or Coexit 9527. For example, it costs around 50 US or 63 Canadians per gallon of Coexit 9500, which sounds cheap, but saying that the Gulf of Mexico oil spill used around 1.84 million gallons of oil dispersal, which cost approximately 92 million US dollars or 116 Canadian dollars. Now that you know the harmful effects of oil dispersants, you might wonder yourself how we can deal with oil spills now that one of the most efficient and effective ways of dealing it is dangerous to the environment. So what I recommend, in my opinion, is that these engineers set up a system or use something called a bioremediation. The reason why is that it's environment friendly and most convenient and as effective as oil dispersants. But bioremediation uses microbes such as bacteria, fungus, and any other biological microorganisms to feed on or remove contaminated air, pollution, or toxins from environments like the ocean. Unlike chemical methods of cleanup with oil dispersants, it doesn't negatively affect the environment. And the last reason why I think that I recommend bioremediation is that it's more convenient. Since it poses little to no threat to the environment, there's no need to move it after its usage, which is cost effective considering that it requires less equipment, labor, and energy. Also, the microbes can survive the cold conditions of northern Canada, with its limit being negative 25 Celsius or below the freezing point. Thus, I believe that bioremediation should be used in oil spills. Thank you for watching, and this is your host, Gabriel Bella. I hope you have a fantastic evening.
Yeah.